Let's start by having a look at what cybersecurity means. For a long time, we had these lingering misconceptions that security means actually the security team. A group of guys somewhere in the basement parsing green code on dark monitors, or only the job of the DevSecOps team when a launch would come. The reality of a modern digital world is that security isn't a destination, but it's a mindset. It is not the job only for the developers or the security team, or even the job of the client that pays the bills. It's a together as one effort where we all contribute to the same purpose. Think of security like building a house. For example, locking the front door is not only the job of the locksmith, it's also the job of the architect and also the job of the bricklayer. If you have the best lock in the world on your front door, but the architect designed the house with no walls, it won't do any good. Or if you have the best lock on your front door, you have the walls, but the bricklayer leaves a big hole out in the back, again, nothing will save you from it. If a developer writes insecure code, or a manager pushes for speed over safety, or even a user writes his or her personal password on a piece of paper and just leave it on the table, everything crumbles. We are all holding a piece of the shield, and if someone drops their arm, we are all exposed. So let's have a look at how this plays out in the real world, and we'll start with the infrastructure. We often see fire and forget infrastructure, where teams build their infrastructure and treat it like a toaster. So you buy the toaster, you see that it works, you plug it in, you see that it works, and you just leave it there and touch it no more. You can't do this with digital infrastructure. First of all, patches. You must always patch for the latest vulnerabilities. They come up every single day. Beyond just the security patches, you must also check the need for that resource, because why not? Maybe the server is not needed anymore. Second, you must also check the permission that the server has. Maybe you dropped some services and the resource actually doesn't need to talk with X or Y databases or services. You must treat your infrastructure like a garden, not like a toaster. This brings me to a personal story about how even when you try to do everything right, you can still fail. I was setting up a web application firewall for an application for a client. The web application firewall, WAF for sure, is like a bouncer. For example, if let's say your application is a VIP club, the WAF is exactly the bouncer standing at the door, allowing the right people in. He has a list. He should allow this person to go through, and all other persons, for example, person dressed in red, they shouldn't be allowed. So I set up all the rules for this WAF, and to be honest, I was feeling pretty smug about the upcoming pen test that the client organized. Pen test is basically hiring a good guy burglar to try to break into your house to test the viability of the locks. The day came, the pen test started. Everything went smoothly. And then, in the second day, the app went down and then recovered. Of course, this shouldn't have happened, so I began looking at the logs. Sadly, to my horror, I've discovered that I had an oversight, and instead of changing the rules action for the WAF to block, they were actually on count. What does this mean? The bouncer at the door was aware that the criminals were trying to get in. He would allow the bad persons to get in, and counting them on a piece of paper that one came, the second one came, the third one came, and all of them were allowed to get in. So the WAF was just sitting there, counting everyone, knowing that they were bad, but still allowed them in because of my oversight. I've audited a client who had hundreds of security groups. A security group is basically a bodyguard that guards the server and allows the right person through the right door to get in. If the name of the person is on the list, he's allowed in. If the name is not on the list, he's basically always denied. Normally, the rules are very specific. For example, only allow the database manager to talk to the database, or only allow the web server to talk to the entire internet. The problem that I've discovered in the security group rules of this client was that in absolutely every single security group, at the bottom, there was one single rule to rule them all, so to say, that was allowing 0000 on all ports. In plain English, this is like leaving your front door open and also putting up a neon sign above the door with "Welcome everyone, you are allowed to walk just in." This was basically rendering all other rules useless. Even if we have all the doors locked, it is very important to know if someone is trying to pick those locks. This is why we have logs. They act like the security camera footage of your building. Sadly, we see here two extremes. Logs with the highest level of verbosity, showing absolutely everything, that are kept till the end of time, just sitting there, collecting digital dust and massive storage costs. On the other side, we have logs with very low level of detail that are kept a day or a week at max, and after that are just erased, and just when you need them, you can't find them because the security footage has been erased. There is also a third category of logs that should never be done, and actually keeping the logs on the server generating them. What this means is that when the server crashes, or in our analogy, the security camera footage burns, the logs will just burn together with it. This is why you need to ship those logs to a separate remote vault. Now, let's move from the servers to the code itself and the people writing it. I once had a conflict with a client of ours that was working on the WordPress instance. I was managing the WordPress instance, he was writing the code for it. The WordPress instance has a security check, a PHP check basically. What it does, it actually, it's a grammar check only that for PHP that actually checks that the code is okay and no problems will arise from it. The problem between me and the developer came from the fact that his code would always trigger this PHP check and the instance would not accept his code. I had to turn this off because he complained very much that he didn't have the time to actually check why the code was failing. Sadly, this essentially means turning off the fire alarm because he was annoyed by the sound, by the beeping of it, and he couldn't actually cook. This is a case of prioritizing speed over stability of the entire site. This Russian culture often leads to breaking the rules in how we actually merge code. Normally, the code should be merged from a test environment to a prod environment after passing some checks. Think of it as a Broadway play. We have the dev environment, that's the rehearsal room. We have the test environment, it's the dress rehearsal. And after that, we have the prod environment, it's actually the opening night with a live audience. You need a pull request. That's actually a review from another person to guarantee that you are entering production dressed as you should be for the opening night. However, in small teams, due to rushing, this is not always the case. For example, in small teams, there are people that are approving the merge request themselves. It's actually a form of high-fiving themselves, or they're actually skipping the entire approval process. That's like going straight from the rehearsal room of dev to the live audience and waiting for everything to be just perfect. Speaking of modern tools, we must also speak about the elephant in the room, AI. No one can deny that AI has greatly shortened the time that it takes from an idea to get to some kind of proof of concept. Absolutely true. However, with great power comes great responsibility. You can't just paste your secret into an AI chat, or the other way around, paste the AI-generated code into your application. This isn't a secure way at all. Think of an API key like a secure keycard for a hotel room. Once you've pasted it in a public AI chat, it's not secure anymore. you have actually fed the AI tool your secrets. This leads us to the cloud account themselves. We always hear about some firm getting locked out of their cloud accounts, the information stolen, ransomware, data encrypted, hundreds of servers spun up in order to mine crypto. While this is a real concern, the trigger almost never arises from a zero-day vulnerability in the cloud providers themselves. A zero-day vulnerability is a very advanced, never seen before hack method. The hackers don't use this. It takes too much money, too much time, too much work. Hackers get in because someone forgot the API keys in a code repository, or someone user account got hacked. So it wasn't because the vault of the cloud providers was weak. It was just because someone dropped their keys on the sidewalk and the hacker just found them. A perfect example of lost keys happened with a client that I worked with. I built the cloud infrastructure, also the cloud accounts. Everything was okay. I handed everything over. He changed the multi-factor authentication, MFA, with his own, of course. I think of some multi-factor authentication is that code that you get on your phone. It acts like a second lock. Along with the MFA, he also changed the password for everything. He was the only one allowed in. Everything went smoothly. I heard nothing of it. Then, one morning, like 2 years after the handover, he contacted me and to ask me if I still had the MFA for the root account in the cloud that he used. Sadly, I wasn't able to help. The only MFA, the only viable MFA was the one that he had. The problem was that the MFA that he had was on the phone that he had wiped. This is a very hard reminder that you must always keep a backup somewhere. Have your MFA up cloud synced. Even keep a spare phone somewhere in a drawer just for cases like this. Losing the MFA for your root account is like welding your own front door shut. Security principles applied to the machines as well. In cloud, resources use roles to talk to one another. These can have the highest level of detail. For example, this server can only talk to this table in the database, or this function can only read the files in this exactly bucket. But this is not always the case. It takes time to make these rules. The simplest way that is sadly done is a wildcard rule that actually allows the resource itself to do absolutely everything in that account. It basically acts as an admin in the entire account. The problem is that if the resource gets compromised, the bad actor can actually take over the entire account just because it was way easier to write a rule with a star instead of normal rules that target real infrastructure. Sometimes the threat isn't technical configuration, but social engineering. For example, a so-called recruiter contacts a developer. We have this job, are you interested? And they move very fast from, we have the job, this is what you should do, this is what we ask from you, to, yeah, it's absolutely no problem. How much money you need, we can cover that, absolutely no problem. The only thing, you only have to take this code challenge and to actually pass it. The recruiter also comes up with some plausible excuses to why the code can't be run in a virtual machine, and moreover, the candidate, dev, should also take the code challenge while in a Teams or Zoom call with the recruiter, because they don't want someone to be cheating. What's the catch here? Well, the entire repo is filled with malicious code that once ran will exfiltrate the passwords, the crypto wallets, and the repos on the developer's machine. In this case, the so-called recruiter was actually a state-sponsored bad actor that was using LinkedIn because the security filters in LinkedIn messages are way less secure than the ones in Google, Gmail, or Yahoo. It is always a reminder that if something looks too good to be true, it's fake. Finally, I want to mention a user experience that I've encountered last month. I work with a Romanian bank that have made an update to their platform. The mobile app needed to be updated, the web app was also updated. Nothing out of the ordinary till here. I thought that, well, I've done the mobile update, let's also change the password. I log into my password manager, generate a 32 characters password, uppercase, lowercase, numbers, symbols, everything. A highly secure password. Then, let's move on to actually changing the password. Well, bad luck. You can't paste it. You can't autofill it. So I had to type 2 times the 32 characters password in order to change it. And now, I really hope that the mobile app won't ask for it again, and I won't use the web app, because I really can't type the 32 chars there. This is not security. It's actually the opposite of it. Because instead of using a highly secure password, people will just tend to use a very simple one just to be able to type it out. Security that fights the user is actually failed security. To wrap things up, I want to leave you with a thought on why you should never cut corners on security. We often find motives for this. It's just a test. It won't do any harm. We are in a rush. But this always accumulates. As the character Sam Vimes of Terry Pratchett's Discord said, no excuses. No excuses at all. Because once you have a good excuse, you open the door for bad excuses. So when we start accepting good excuses in order to bypass security, we will reach the point where no excuses are needed for that. So let's keep the door closed for all bad excuses and treat security as the foundation of everything we build.